Good morning, sixth class students. I hope you are all are safe at your home. And today we are discussing about our chapter number 4. It's a second video. First video we already discussed in first video. That is appearance and how materials are, how matters from the matters we have to make a materials. And now today we are discussing about some properties of materials. Means in first chapter, first video, we already discussed about the appearance. It means how they look and how they shine, and what are the how much the percentage of and strength of that shining. And so appearance means they are lustrous, like metals, gold and silver are generally having the lustrous materials, and some other non-metals are having a poor shining things. Okay, poor, they are having the poor shining. Now we are discussing about some more properties of these materials, and in that, second is hardness. Second is hardness. So listen, that is on the page number 43. Hardness. Materials are grouped according to their ability to be compressed or squeezed. It means materials are grouped according to their hardness. It means the compressed or squeezed. Compressed means how they can be reduce their size or squeeze. We can easily squeeze a piece of sponge between our fingertips, but we cannot squeeze an iron ball. It means iron ball we cannot squeeze. It means we cannot suppress. It means we cannot press into a different shape, but we have to press a sponge into our fingertips. Even if we press it with all our might, therefore we say that sponge is soft while iron is hard. Okay, so that's why we are telling that sponge is soft and iron is hard substance. Metal like lead, aluminum, copper, and metal like wood, stone are hard. So, like some metals like gold, silver, iron, okay, they are generally having the hard surface. They are having the hard surface. But some like wood, stones, and they are also hard substance. Chalk, cotton, wax, etc. are all soft materials. Chalk, cotton, and wax are soft materials. The shape of hard objects cannot be changed by applying any amounts of force, but the shape of soft objects can be altered easily. So, with the shape of hard or solid objects, we cannot change into the another one, mostly by the suppressed or by the compressed, but we can change the liquid or some gaseous objects into the squeezed or maybe compressed into the different shapes. The properties of hardness of metals decide the purpose for which it can be used. It means the property of hardness. It means how anything or any substance is hard. On the basis of that, we have to clarify that this object or these things, how we have to use for the different uses. For example, the materials used for making vehicles, houses, roads, etc. should be a hard, while clothes should be made of soft material. So, according to needs, according to their textures, according to their states, we have to use, like for making a breeze, we have to use some hard objects, okay, and like for wearing purpose of like clothes, we use some soft materials. We use some soft materials, okay. So the soft metals can also be scratched with our nails, but not the hard metal. We can easily scratch a candle made of wax, but it is not possible to scratch a wooden pencil. So the scratching properties, it means scratching we have to do only with the some liquid or some soft material. But for the hard objects, we cannot make any scratching. Material can also be smooth or rough to touch. The surface of steel, utensils, polished wood, etc. are smooth. Bricks, rocks, soil have rough surfaces. Therefore, the material can also be classified according to their smoothness or roughness. So, metals also can be classified as a smoothness or roughness. Luster, hardness, roughness, or smoothness are some of the properties which describe the appearance of a material. In addition to this, we can also describe the appearance of a material by its size and weight. So, you know about that luster. Luster means this appearance, how anything is look. Hardness or roughness is the same thing. Okay, or smoothness are of the some properties which describe the appearance of a material. It means how any objects are generally looking in nature. We can describe with the help of these properties like roughness, hardness, and its appearance. Okay, and smoothness. So in addition to this, we can also describe the appearance of a material by its size and weight. So by the help of size and weight, we also have to see how they will be appear. It means how they will be the appearance. What will be the appearance? Uh, whether whether it is a large or small, whether it is a heavy or light. It means maybe some we can divide the category wise, like some are the light, some are the in weight, some are small, some are in heavy. Okay, so these are some more properties which distinguish about the anything to make a more comparatively study about that. Okay, now the solubility, materials or substances like sugar or salt when mixed with water disappear completely in it. Like solubility, sometimes you know about that some objects or some substance can be easily soluble in water, but some cannot be soluble in water. So those are good soluble, like sugar, salt are good soluble in water, and like soil, chalk powder are the insoluble in water. Okay, so on the basis of solubility we also describe the properties of materials. Okay, so sugar can dissolve in water, but sand cannot be dissolved in water. So sand is generally not soluble or insoluble substances. So here we say that sugar or salt has a dissolve in water. Substance which dissolve in water are known as soluble substance, and sand and chalk powder do not dissolve in water, so they are said to be an insoluble substance. So I hope you understood, and from lower classes you already listened that or studied about that chalk and sand powder are generally not soluble in water. That's why they are insoluble substance, and sugar and salt are soluble in water. That's why they are soluble in soluble substance. The substance which dissolve in a liquid is known as solute. So, like the substance which dissolve in liquid, like if we are having the two things, like in a glass of water, so sugar, which will be the dissolve in water, that is known as solute. That is known as solute, and which are having the minimum amount, which are having the minimum quantity, that is a solute or sugar. And like other is that water. Okay, water, which is a solvent, which is a solvent. Okay, so which is the more quantity in maximum quantity in our glass, so or maybe in the solution. So you know about that solute and solute, when they will it is added, we will make a formation of solution. We will make a formation of solution. Okay, so this is the solution. This is the solution. So listen, the substance which dissolves in a liquid is known as a solute, and the liquid in which a solute dissolves is known as solvent. So the solute and solvent together means when they will mix with together solute and solvent, this is there is known as solutions. Water is the most commonly used solvent since it readily dissolves a number of substances. So therefore, it is a universal solvent. Water is a universal solvent because the many substances in the whole world, only water is the liquid or solvent in which more number of substances can be dissolved. So that's why water is a universal solvent. Some liquids like glycerin, vinegar, lemon juice dissolve in water to form a solution. They are known as miscible liquids. It means if one liquid is just mixed with the another liquids, one liquid is just mixed with the another liquids, like lemon juice plus water. So they are known as, if two liquids are it means just mixed with them, they are known as miscible. They are known as miscible liquids. And if two cannot join with, if two cannot mix with each other, like that, oil plus water, so they are known as immiscible. They are known as immiscible. Okay, so I hope you understood about that. What is miscible? A miscible word generally we are using for two liquids. Okay, it means two liquids which can soluble in water. It means two liquids which can mix into the two liquids which can mix to each other. Okay, and immiscible means two liquids which cannot be mixed with each other, that is known as immiscible. Okay, and soluble, generally we have to use this word and this particular terms only for solvent, or it means for the hard substance, for the solid substance. Okay, so they are known as miscible liquids. Vinegar, lemon juice, vinegar and glycerin are miscible with each other. In both the cases, the solvent used is not water. So cooking oil. Okay, sometimes solvent we cannot use one solvent is a water. Sometimes vinegar, glycerin, and vinegar and lemon juice also can be mixed with each other. Cooking oil, kerosene oil, petrol, etc. do not dissolve in water. They separate into two distinct layers when kept undisturbed for some time. The liquids which do not mix with each other are known as immiscible liquids. Gases like oxygen and carbon dioxide dissolve in water. These gases help the aquatic plants and animals to carry out the process of photosynthesis and respiration. Like gases sometimes. Gases also mix with each other, like O2 and CO2, it may dissolve in water. And these gases help the aquatic plants and animals to carry out the process of photosynthesis and respirations. So, like oxygen and carbon dioxide just dissolve in water. That's why aquatic plants and aquatic animals can survive in the water. Some aerated fizzy drinks, it means some like Coca-Cola, Pepsi and lemon, Mirinda, like okay, Limca. So these also are having some different type of gases like carbon dioxide in dissolve form in water under pressure. Okay. So now activity 4.2, that is to separate two immiscible liquids using a separating funnel. Okay. So first we have to take a transparent plastic bottle, a rubber tubing with a regulator, two beakers, a mixture of kerosene oil and water. So these all things are seen in the diagrams. Okay. So cut the base of the plastic bottle. Okay. So we have to cut the base of this plastic bottle and make a hole in its cap. At the hole, we have to make a cap at the hole at the cap of this. It is the mouth of the cap. And this is the separating funnel that you have made. Pour the mixture of oil and water in this separating funnel and allow it to stand for some time. It means this is the oil and water first in the mixed form, and after some time when we are not disturbing, it means the undisturbed for at least 15 to 20 minutes. After that, automatically the oil will be it means comes upside and water at the downside. Pour the mixture, okay, separating funnel, allow it to stand for some time. You can see that oil and water separates into two different layers. Okay. So oil and water into two different layers. So here it is a made a layer in between them. Then place a beaker below the separating funnel and allow the lower layer of water to run out for adjusting the regulator. Okay. So here we have to make like a nozzle like things in which we have to pour this water to by dropwise into one beaker, and when the time of when water is just completely it is down, fall into this beaker, then we have to make stop, because now rest substance is only oil. So by this or through this it means separating funnel, so we can separate the oil and water. Okay. So place a beaker below the separating funnel and allow the lower layer of water to run out by adjusting the regulator. Turn off the regulator when the water gets collected in the beaker. It means once the water will just goes or to run out through this thing and can hold this water can be taken up in this beaker, then we have to turn off this regulator and keep oil in upper one plastic bottle. So repeat the same procedure to collect the layer of oil in another beaker, and separating funnel is used to separate a mixture of two liquids which do not mix. It means separating funnel only used when two liquids cannot be cannot be mixed and they are immiscible in nature. Then that type we have to mix. That type we have to separate this by the help of this separating funnel. Now the fluotation. Certain materials float on water whereas others sink. So certain materials float on water where others are sink. It means some materials can be float and on water, and but other can sink. Sink यानी डूब जाना. Okay. So this property is called fluidation. Generally wood, leaves, plastic paper and feathers float on water, where rock, glass, honey, sand and metals are sink. It means some substance can be sink into the water and some substance cannot be sink. It means they can float on the water. So we can test this metal to see whether any substance is float or sink in oil. The metals which sink in water will sink in oil, since oil is lighter than water. Okay, so those metals which sink in water, maybe they will sink in oil, because oil is lighter than water. Oil is lighter than water, and the metals which float in water may float or sink in the same oil, depending on the density of oil and the density of the metal. So sometimes the metal which float in water, okay, initially they are generally float in water, but maybe float or maybe sink in some oil, same oil, depending on the density of soil. Because if there are too much dense, they can be maybe float, and there are the density is low, then maybe some substance can be sink into that particular oil. The object which float in water will remain floating. Floating and sinking of other objects will depend upon density of the liquid and the density of the materials. Why do you think a metal ball sinks in the water, whereas a ship of metal stays afloat? It means, why you think that? Sometimes you think that iron nails are, when you are dipping or just sink into the water, but too much heavy and taken a too much long burden of heavy weights of many containers, the ships can even float on the water. Okay, they cannot sink into the water or in the oceans or seas. So on the behind that, we are having the one buoyancy, or like one buoyant factor is there, and for that Archimedes principle we will see in the class 9th. Okay, and here also we have to we will see, because after the density. Okay, and before the start to transparency, here it is written that answers. Okay, so density is a property of matter that describes how heavy an object is for a size. It means density is a property of matter that describes how heavy an object is for its size. Any substance is how heavy, and how it means its size will be the having. It means, okay. So density compares the weight of a material to its volume. Density compares the weight of a material. It means they will also compare with the weight of material to its volume. Okay, because B is equal to m upon V. This is the formula for us. B is equal to m upon V. So it is a density is equal to m upon V. M is mass. Okay, and this is the volume. So you know about the density is directly regulated, or it means linked with mass and volume. Okay, if their mass are too much heavy, then density also are heavy. But if their volumes are less, okay, volumes are less, then maybe density are the heavy. It means due to sometimes the volume is less, then density is very heavy in nature. Okay, so this formula also we will see in higher classes. So in some matter, the molecules are more closely packed together. These materials have a higher density. Scientists compare everything to water, which has a density equal to 1 gram per centimeter cube. So water is having 1 gram per centimeter cube. 1 gram, because this is the mass 1 gram and centimeter cube. Okay, so that is the volume of that container. Okay, or maybe the any vessels. So when the density of material is less than 1, it will float in water. It means if the density of any substance is less than 1 gram centimeter cube, then it will be float, and if the density is more, then it will be a sink in water. Okay, and materials with a greater density than 1 will sink in water. So can you now answer why object sinks or float in water? When a stone is dipped in water, is placed in water, the water level rises. In this case, water is said to be displaced. So you know about that. When a stone is placed in water, the water level rises. The water level rises. You know about that. If when we are having a one glass, okay, and when we are keeping this water, okay, the level before that, okay, before that level is this much, and when we are adding a one stone, the level is just increased. Okay. So when stone is placed in water, the water level rises. In this case, water is said to be displaced. Water is said to be displaced because the place of water is taken by stone. The place of water is taken by this stone. That's why the water is just displaced. Okay, and take the volume of another one more. It means one more area. They can attain some more volume of that particular vessels. So move somewhere else by the stone. If the weight of this displaced water is greater than the weight of the stone will float. Here I am describing about the Archimedes principle. What the Archimedes principle will that like that by the stone. If the weight of the displaced water is greater than weight of the stone, it means weight of the look that this is the stone, this is the water. Okay, this is the water can be displaced by this stone. So we have to compare this displaced water, okay, displaced water with weight of stone. Okay, displaced water, it means weight of displaced water. We have to tell weight of displaced water with weight of stone. We have to make comparison in between that. Okay, so if the weight of displaced water is greater, okay, so this displaced water is a greater than, it means look, this is the greater, this is the, if this is the greater, okay, and of stone, weight of okay. It means if condition we have to found that weight of displaced water is a greater and weight of stone is a less in weight, then the stone will float, otherwise it will sink. So in this condition, stone will float. Stone will float. Stone will float. Okay. It means if weight of displaced water is too much high and weight of stone is less than that, then stone will float, and if it will be the change, then stone will sink in that particular water. So the shape of the object also affects the amount of liquid it displaces. Certain heavy objects are able to float because of their shape, like ship. They can float on the water only is due to their shape also. Okay, so because of their shape, for example, the shape of ship allows to float on water despite the fact that it is a very heavy. So ship is a very heavy in nature, but they can float on water. So one reason is of that their shape particular, and second thing is weight of displaced water, which is a more, and weight of stone. It means weight of stone is a less in that, then it will be the float. Okay, otherwise it will be sink in water. It will sink in. So that's why the shape of iron nail, okay, generally showing like that to sink only, and they cannot be displaced water too much. That's why they are generally sink in water. Okay, so I hope you understood these things. In next class we will study about this. So this we have to over, this we have to over. So three properties we have to see today, and these three properties like transparency, thermal and electrical conductivity, and magnetic property we will see in our next class. Okay, thank you.